Okay, in this problem, a grocery store has 23 2-liter bottles of Diet Cola on the shelf. So, 4 have exceeded their shelf life date. You randomly select 3 bottles of cola without checking the expiration date. So here we are going to do the hypergeometric distribution because we are selecting without replacement. We're selecting 3. We're not putting them back. So this will be a hypergeometric distribution. So what we need to do is figure out N, the population. Okay, so N is going to be your population size. So here our population size is 23 2-liter bottles. R is the number of successes in the population. So when we looked at our population, 4 had exceeded their shelf life date. So that is our number of successes. N is the sample size. So we're going to randomly select a sample of 3. So N is 3, lowercase n. And for A, determine the probability that none. So X is going to be 0. So when we put this in, it's going to be 0, 3, 4, 23. And then we can just put false because we don't want it to be cumulative. We just want it to be X equals 0. So let me show you how I did that. So I put in 0 for X, 3 for the number of my sample, 4 for the population successes, 23 for the number of my population, and then here, cumulative, I'm going to press false, and you get 0.5471. Okay, now the probability that at least 2 bottles have exceeded their expiration date. So at least means 2 or more. So what we can do is we can get the probability up until 1.99999 instead of 2. And what that's going to do is, let's just say 2 is right here, and we want it to be at least 2. So we need this, but to get this, we're going to find the other side, and we're going to say 1 minus the probability of the other side to get the greater side. So we're going to put, everything's going to stay the same except for the 3, for the 0, we're going to put 1.9999. And we do want it to be cumulative because we want everything all the way up till not quite 2. So let's just go in there and change the 0 to 1.99999 and false to true. And so the area of the yellow is 0.9334 all the way up. So 2 or more would be the other side. So we're going to say 1 minus the side we don't want. So if you do 1 minus 0.9334, you will get 0.06. Now, so you get 0.6 if you round 0.0667. Let's look at it in Excel just to make sure. 0.066. Let's look at it here. 0.0667. But I think it can be plus or minus 1 here. Okay, let's look at the next part, the mean and the standard deviation. So to find the mean, you're going to do, if you look in the blue here, n times r divided by n. So we know that n is 3, r is 4 over n, capital N. So that's going to be 12 over 23. And 12 over 23 is going to be 0.522, which is what we get here. Now let's look at the standard deviation. It's a little bit more complicated, a little bit more calculating here. So you have the square root of n times r, 3 times 4, times n minus r, 23 minus 4, over n squared, and then you're going to do the square root of capital N minus lowercase n over capital N minus 1. So 23 minus 4. Okay, so 3 times 4 is 12. 23 minus 4 is 19. So we're going to do 12 times 19 over 23 squared. And I'll go ahead and do 23 squared. So 529. Then over here we get 20 over 22. So 12 times 19 divided by 529. Okay, and then we want the square root of that. So we end up with 0.656507 is what I'm going to put. Let me make sure that's right. Okay, and then we're going to do 20 divided by 22. And you're going to do the square root of that. And you get 0.9534. I'm going to round it to that, just to be exact. So 0.656507, and you could do this in Excel, times 0.953463, and you end up getting 0.626, which is the standard deviation. So let me know if you have any questions about this.